Hello, hello. Can you hear me?
Hello. Yeah.
And my slide is visible to you. Okay, so we will start today's session after 4 minutes. So we have to wait 4 minutes.
For energy.
Hello, sir. Can you hear me?
Yes, sir, I can hear you.
Okay, thank you. So let's wait 4 to 5 minutes, then we will start.
Okay, sir.
Okay, thank you. Yes. Can you see my slide? Okay, so let's try this question. Hello, sir. Regarding the question paper also objective and also numerical, NAT. You're, you are muted, sir. Please unmute yourself.
सर जो आप कह रहे हो कि क्वेश्चन पेपर जो है वो ऑब्जेक्ट टाइप रहेंगे.
Yes, objective plus numerical, NAT, fill in the blank, like that. Value, we have to
Okay,
calculate the value.
exactly. So whatever we are discussing, we are solving in the assignment. Right now also we are solving, sir. There is a numerical and there are multiple choice questions. We need to solve the numerical and then fill the answers, right?
Yes.
Okay. Today I went through that information in the announcement section.
Okay.
So it will be computer based, right?
Yeah. And calculator also allow.
Online calculator is allowed, sir. Right?
Okay. Yeah. I think
Mhm.
offline maybe you should take a offline calculator like.
Okay, sir. Okay. Okay. Mobility nu is equal to
You can use this formula mobility
over here.
mu n equal to q. This
Yes,
formula
yes.
q is a electronic charge, tau n is a mean time, electronic mean free time, mn is a mass of the particle. R is given, m naught is a rest mass of electron.
Okay, sir. एक minute. Please give us a few minutes.
And also we have 108 picosecond. And we know the q. So
We'll answer A.
yeah, so this is the first question. Please try to solve this. This is the formula for movability, and all other parameters are given to you. Please calculate the movability, also the mean free path.
कैसे कर
Yes, please write the answer in chat box. So we have to also calculate the mean free path. How we can calculate
Acha, mean free path.
also 33.7 nanometer according to this, but please find option A is correct. We know the distance upon time. Sorry, VTH.
VT.
So thermal. This is D or L. But T is we have already calculated. So we have T. So we have to find thermal velocity. How we can calculate? So here is a concept. Please look. You know kinetic energy.
V square is equal to 3 by 2 kT.
Yes, we can apply 3 by 2 kT. Degree of freedom for this air 3 by 2 kT. So please apply this concept also here. This is the formula and this is another formula. After finding VTH, we can apply mean free path L equal to VTH into tau n. Please find now. Let me show the report to you properly. Please find pressure also. We have to find the movability. What is the formula? Q tau n and Mn. This is the formula and we have parameters tau n, picosecond, at temperature also is given. Electronic movability we can calculate. M naught is here 9.1 P10 to the power minus 31 kg. Please solve this. This is around I think 1000 in centimeter square per second. We have also find mean free path. So 3 by kT equal to we have to apply this formula. Please get a value at room temperature. We know in electron volt. Put this value, find the value of VTH 2.2 at 10 to the power 7 centimeter per second. So mean free path VTH into tau n. This is the concept. Three by two KT, and this is also a formula. Please remember. Transparency is very low. Okay. So let's move further. This is the first question. So here is a graph that I discussing. One minute. So please look this graph. Movability also vary with temperature, impurity or lattice scattering also. So with the impurity 3 by 2 power, while lattice minus 3 by 2. Electronic mobility in silicon versus temperature for various donor concentration. Insects show the theoretically temperature dependency of electronic movability. This. So let's move for other question. Which of the following type of silicon exhibits lowest carrier movability? We have already seen graph. If impurity is high, then movability is low. So which silicon has more impurity? Okay, so C is correct answer. Amorphous silicon has more. So here is also about the movability. Electron definition, electron mobility is a characteristic how quickly an electron can move through a metal or semiconductor when pulled in an electric field. And this is the formula V d equal to mu into E. VD is the drift velocity of electrons, thermal velocity or drift velocity, sorry, VD. So semiconductor depends on the impurity concentration, including donor acceptor concentration, defect concentration, temperature, and electronic hole and concentration, electrons and hole concentration. Also depend the electric field, particularly at high field when the velocity saturated occur, it can be determined by the Hall effect. Okay. So next question. The starting material in the manufacturing of semiconductor grade silicon is semiconductor grade silicon. Which type of silicon? Silicon vapor, silicon tetrachloride, silicon melt, trichlorosilane, siloxane. So D is the answer. In Siemens process, the starting material is trichlorosilane for the silicon semiconductor silicon grade. Okay. Next question. Which of the following belong to the second generation solar cell technologies? Third generation, second generation, third generation solar cell. So please look into the meter. Second generation solar cell. Which type? So let's see the answer. B and E is the correct answer. Amorphous silicon and cadmium telluride. And in the third lecture also, second generation solar cell, thin film solar cells, inorganic materials to reduce the material cost and to reduce the amounts. This type of solar cell is second generation solar cell. The process used for manufacturing semiconductor grade silicon is a Grade silicon. And question is about grade silicon. A and D is correct answer. Siemens process and union carbide process. That we can obtain the grade silicon. Okay. In previous question, let's see which type of. So you can visit. Here is a site. Let me show you. So here is a chart. Technologies and efficiency pairwise. You can see here is a downloader technique specified crystalline silicon single junction multi junction thin film and emerging PV. Okay, so please visit this site regarding the solar cell efficiency and technologies. And which group has get highest efficiency also mentions here. Are you able to see now clearly?
Yes, sir.
So two terminal, four terminal also the here is the four terminal highest 47.6. All junction solar cell. So silicon is generally we have seen in our rooftop this type is a single junction solar cells. For space and other application, people have used higher efficiency solar cell, also stable. So please look this site also.
So what is Joklarski process? Because somewhere I found Joklarski and Siemens process use as a similar, same process.
So okay. There is a book SMG you can find and let me show you. Please read this book about the process. Semiconductor PDF books. Please follow this book and I will show you two chapters also. Yeah, please follow this book, FMG, and chapter 11 chapter, single crystal growth, float zone process, all techniques are there regarding the silicon. Let me show you chapter 11. Yes, please. This is chapter the starting material for silicon, Lichci Cholsky technique also for obtaining the silicon. This step, please look carefully. Silicon grade or other things. There is a first, and numerical is also there, and float zone technique. There is a nice diagram about the process technique setup also. Please look and read this.
Okay, sir. Thank you, sir.
Okay, and let me check out gallium arsenide also technique here. Crystal growth. Okay, so please look this book. So answer is, which of the following belong to the second suggestion we have already discussed. For grade silicon, indium carbide and cement process. And sir already discussed semiconductor grade silicon. Please look this slide also and lecture notes. So next question is, plot the doping distribution arsenic at a distance of 10, 20, 30, 40 and 45 centimeter from the seed in silicon. In quote, length is 50 centimeter long that has been pulled from the melt with the initially doping concentration 10 to the power 17 per centimeter cube. Cannot is the arsenic coefficient. Okay. Book name is SN. SMG. So this is the question, and how can you solve? Let me put a formula for this question. Then please try to solve. Here is given cannot for arsenic 0.30 and C naught initially concentration per centimeter cube. So this is the formula K naught C naught, sorry, 1 minus L by L naught K naught minus 1. So we have to find total doping distribution arsenic at resistance. We have already given L not equal to 50 centimeter and L also given 10, 20. So we have to find CS distribution, doping distribution of arsenic. So this is the formula. Please try to solve and plot roughly. We have 5 minutes. Please try to solve this question. Sorry. Yes, please check your answers around this. Plot the doping distribution also. So we have to CS and L with length. Rating is increasing like that. So you can plot in chart. um, Okay, so let's move for other question. Yes, please. Which of the following is a correct sequence for manufacture of single crystal silicon? Others, please answer. So C is correct answer. First metallurgical grade silicon, then purification, then semiconductor grade silicon, then melting and solidification, then single crystal. That's why this cost is very high. Silicon wafer. So next question. The Cholsky melt is a simultaneously doping with boron at level 10 to the power 17 atom per centimeter cube and phosphorus to a level 18 to 20 power 16 per centimeter cube atoms. Does a p-n junction form during this growth? And if so, what is the fraction solidified? So we have also used previous formula. Kf C naught K naught 1 minus L by L naught or M by M naught we can use. And M by N naught is fraction solidification fraction. So question is, does it form p-n junction during the growth? What is the criteria for p-n junction doping criteria? This is the hint we have to look What should be the doping for p-n junction? N side and p side. Then can form p-n junction. So please think. You have 5 minutes. I- This is the formula you can apply, but please think. What should be the doping concentration? CS, both side, N side and P side. Then can p-n junction form. You can take 5 minutes for this question. Please solve. As for p-n junction, let's say this is p side doping and this is n side. Should be equal, then we can form p-n junction. Now please solve this question. M by N naught. All parameter are given. Boron and phosphorus. Phosphorus is cannot is given, sorry. Boron, let's say boron. For boron, 0.8. Please take this data. Now please solve. What is the value of M by N naught solidification fraction? These represent boron and P is phosphorus. We have to find M by M naught. Now please solve and tell me the answer. Yes, please answer. Please put the value. This is boron and this is phosphorus. Yes, please solve this equation for M by M naught. What is the answer? Is this 0.903? Yes, please respond. This is the simple equation. Please hold. Yes. This is 0.10 to the power 17. Cancel out by this. And what is remaining? 1 minus m by m naught to the power 0.35 minus 1 and okay. Please hold this power. So after taking power root, this please look. Okay. Can I move further? Yes, please. Yes or no? Okay, thank you. Let's move. Which of the following is belonging to the family of chalcogenides? Option A, cadmium sulfide, selenium arsenide, amorphous silicon, cadmium telluride, polycrystalline silicon. Which option is correct? So cadmium sulfide and cadmium telluride, these are the family of chalcogenide. Chalcogenide is a chemical compound consist of at least one chalcogen anion and at least one more electropositive element. Although all group of 16 elements of the periodic table are defined in the chalcogenide, the term chalcogenide mostly common as reverse for the sulfides, selenides, tellurides, and polonides rather than the oxides. Okay. Next question Which of the following is a commonly impurity element? Metallurgical grade silicon. Commonly impurity or metallurgical grade silicon. Yes, B and D is also. Production of metallurgical grades, you can see is this is the procedure for the metallurgical silicon, and you can see aluminum 0.4 to 0.7% impurity, Fe, calcium, Ti, and carbon. Okay, the intermixing of cadmium sulfide and cadmium telluride layer in the cadmium telluride solar cell leads to intermixing. Option 4 are given: increase quantum efficiency at lower or higher wavelength, or decrease at lower and higher wavelength. Sorry, question I want to get. Yeah. So decrease in the quantum efficiency at lower wavelength. Quantum efficiency at lower wavelength. This side is high wavelength, this side is low. So blue response is reduced due to the front surface recognition at lower wavelength. And red shift is also reduced due to the rare surface recognition, reduced absorption at the long wavelength and the low diffusion length. This is the quantum efficiency curve with wavelengths. These are the three reduction in quantum efficiency. First is blue, then in between a reduce of the overall quantum efficiency caused by reflection and low diffusion length. And third is red shift, red response. Okay. The type P-type characteristic in gallium arsenide can be enhanced by which type of substitution? P-type. Yes, please. How can we P-type characteristic improve in gallium arsenide? Arsenic with zinc. Doping in the gallium arsenide N-type doping. These are the options for P-type. These are options. Okay. Next question, which of the following can be used for window layering in gallium arsenide solar cells? For window layer, the others, let's check. B and D are the answer. Please, for gallium arsenide, divide band gap this much 1.41. Band gap of the gallium can be tuned by doping this. So higher carrier movability silicon. So indium and aluminum can be used as a window layer for gallium arsenide solar cell. Cadmium chloride treatment in the cadmium telluride solar cell result in yes, please read the question and option carefully and answer the question. Larger grain sizing, cadmium telluride films, pure crystallinity and time characteristics, reduce reduce defect density, reduce relative recognition. Yes, please. For what purpose? Cadmium chloride treatment in cadmium telluride solar cell. Others, please answer. So let's see the answer. A also, A and B. Larger grain sizing and reduced defect density. If the defects is less, then it may be also impact the grain size is high, larger. So D and A is the right answer. Okay, so please follow the sir lecture also. Today we have discussed first question we have discussed about the movability calculation. And Please look this curve also. Impurity and lattice scattering. Impurity how can vary in this insect. 3 to the power 3 by 2 and 3 to the power minus 3 by 2 with temperature. And this is the two formulas for movability and diffusion length. And this is also carrier movability question. And these are the Siemens process. Please learn these things also. Reactions in process. And type of generation solar cell, first, second, third, and fourth. Process that is manufactured semiconductor silicon, which type of process used for grade silicon, grade. And this is also the question about the concentration doping distribution. And follow the steps during the single crystal. And is also the question about the PN junction. This is the chalcogenide about. And impurity element commonly used in metallurgical grade silicon. And this is about the cadmium telluride solar cell intermixing quantum efficiency. Please look carefully this quantum efficiency curve. Which response is due to the which recombination, and due to efficiency, quantum efficiency is reduced. Okay. Please look all the assignments and 2014, which is in sites. I think you have already solved and submit assignments and follow the lectures. Carefully. I think that is enough. And I think sir is also suggest the books you can also follow. But first, carefully look the assignments. And numerical also, which type. Similar question may ask in exam, but numerical value or something is different. Question paper may be simple, like data assignments. This is objective with the NAT question, numerical type answer. So this is all about today. Your exam when? When will be your exam?
24th.
24th. So next Monday.
Next Monday is 18.
So okay, so next class is 18, then your exam 24.
Yes, sir.
Holika Dahan.
Holika Dahan. Yeah.
Okay. So okay, thanks.
Okay, sir.
So
Thank you.
we will next month. Thank you.